Welcome, my name is Robert Magee from SideEffects, and today I would like to talk to you about Houdini Foundations. As an artist new to Houdini, you are sure to have lots of questions about Houdini and its procedural, node-based workflow, and this presentation will set you on the right path. Houdini Foundations GDC 2018 edition is a 96-page book which is available as a PDF on the SideEffects.com website. This book is designed to teach you fundamental concepts and ideas and includes 4 main chapters. The first chapter explores the Houdini interface elements and introduces the specific language used by Houdini and its procedural node-based workflow. Next, you will find the first tutorial chapter where you will build a soccer ball, texture it, then animate it using keyframes and simulation. You also learn how to bake out the geometry to low-res mesh, then export a simulation to Unreal Engine 4. The next chapter explores the use of the Houdini engine, which makes it possible to open procedural assets in other applications such as UE4, where Houdini works under the hood to cook the nodes and networks and deliver geometry back to the host application. The final chapter explores the use of volume-based height field tools for generating digital terrains. You will build up a simple landscape, then export it to UE4. To start, let's discuss what makes Houdini a great solution for creating art for your games. Houdini has tools for procedural modeling, terrains, environments, effects, and more. What makes these special is that all of these tools in Houdini are procedural, which means that everything you do creates a node. You can then wire together these nodes to create a flow of data that can be used to easily go back and make changes, or to package up a workflow and share it with other artists. There are many different kinds of nodes in Houdini, and they live in different network types that each focus on a different aspect of a scene. For instance, surface nodes let you work with geometry. Channel nodes let you work with motion. Dynamic nodes let you set up simulation. Vex nodes are for building shaders. And compositing nodes are for creating composites of your renderings, or to build up images you can use as textures in your scenes. Render nodes are also used to contain all your render output settings. Now, as you start working with Houdini, you will encounter what I like to call the secret language of Houdini, which references these different node types. You see, nodes were originally called operators in Houdini. Therefore, you have SOPS, CHOPS, DOPS, etc., which represent surface operators, channel operators, and so on. If you meet a veteran Houdini user, you may very well hear this secret language being used, so it's a good idea to be aware of its existence. Let's start by taking a look at geometry, or SOPS. We'll use the soccer ball tutorial from the first lesson in the Foundations book to explore this area of Houdini. Before we start, let's take a quick look at the workspace. At the very center you have the scene view, which is where you'll do your actual interacting with 3D objects. And then you have the network view. This is where the nodes are going to go. So as you build something in the scene view, nodes will appear in the network view and they will get wired together. When you select a node, you'll also see parameters that you can adjust, and they'll be available here in the parameter pane. Similarly, there is a tool shelf up at the top. It will allow you to work interactively with objects in the scene view, and will create one or possibly more nodes in the network view. Down at the bottom, we have the timeline. This is where you will press play to check out an animation or to run a simulation. So let's get started. We're going to begin by creating a cube or a box in the scene. We're at the object level. We're going to dive down to the geometry level. We're going to manipulate the handles of that box. Then we're going to select all of the pieces and do a poly extrude. Now, set that to individual elements and we can manipulate the handle on that node. Now you notice that both the things we've done, the box and the poly extrude, and now the subdivide, all have nodes that are in the network. And I can select any one of them and manipulate the handles for that particular node, or I can set the display flag on the different nodes to display each one of them individually. I can take out the poly extrude, put it back in. It's non-destructive by nature. And this is how you can begin to work in Houdini. So now we can put a node directly in here, a platonic node, and we'll get rid of the box, basically swap it out. This time we'll set that up to a soccer ball. We can go to the poly extrude, grab the handle, push that in, and there we go, soccer ball done. Well, not quite. This is a cheap plasticky looking soccer ball, and not exactly the one that we'd like to use. So what we're going to do is we're going to alt-click to drag these nodes over here. We're going to put the subdivide before the polyextrude so we can get a little bit more smoothness in the soccer ball. Now, right now this will polyextrude all the individual faces. That's not what we want. And the soccer ball is a little wonky in shape. So what we're going to do is put down a ray SOP and put down a sphere. And what this will allow us is project the points of the soccer ball out to a better looking piece of geometry. Now, again, we can polyextrude them all individually or as a group, but we want to do the original patches. So what we're going to do is put a attribute down where we're going to go down, we're going to call it patches. We're going to use @primnum. So we're going to take the primitive numbers from the original soccer ball geometry and promote that up as a primitive attribute. Now let's see what that means. So we can actually visualize that in the 3D view here using a patch marker. And we'll set this to patches. And what you'll see is that if we go back to the soccer ball here, you'll see each of these polygons has an attribute number and how it's been promoted up into these different patch areas. So each patch area has that specific attribute. Now how is this going to help us? Well, we're going to set up a for each loop where it's going to go through and polyextrude each of those patches individually. So we're going to go patches in here, and as you can see, each one of them has been done and then brought back together and merged together. So then we can fuse that, put a polyextrude down or a subdivide down there, and there we go. Much better looking sort of soccer ball. If we go back to the for each loop, we can actually go through and run through those different patches, or say give us the whole thing and combine it together. So the next thing we can do here at the geometry level is also set up UVs. And what you're going to see is instead of setting it at the end of the chain, we're actually going to insert it a little bit earlier on. We're going to put in a quick shade node. That sets up UVs, but not the ones we want. So we're going to put a UV flatten node down, and this will allow us to get the UVs that we want. So as you can see, we've been able to create a flow of data using geometry nodes that have allowed us to build up geometry and also spit out some UVs. The next thing we'd like to talk about is materials and baking. So we're going to set up a material that we're going to assign onto the soccer ball, and then we're going to bake the high-res version of the soccer ball into a low-res texture maps that we can use for our game. So let's start back where we just finished, and we're going to go in and put a principled material down. We're going to then assign it down here at the geometry level. And if we go back to the material node, we want to set the base color to white, and we want to use a texture map. Now if we assign that texture map here into the UV view, we'll see that there's actually a logo there, and what we'd like is a specific patch. This patch right here, for instance, we're going to pin this patch, select that patch, press enter. We're going to move that up to where the logo is and press R to rotate that around. Now will allow us to get the UV flattened to do what we want. Now it creates some overlapping patches, so we then press the repack button to reorganize a little bit, and there we go. We've got the logo where we want it, got our UV set up. Now we can assign texture maps to other things like reflectivity, roughness, and also we can put a little bit of a bump or a normal map on there to create a little bit of texture to it. And we'll just reduce the influence of that a little bit. So there we have the soccer ball all textured up, ready to go. And what we'd like to do is have this work as a low-res piece of geometry. So we're going to go back into the network, and we're going to use a part of the original network. We can take those three nodes, and we're going to just alt-click to drag those over. Notice how within the SOP environment we can branch off and try new ideas. We're going to go in and take the subdivide node and go 1. And you see this is a much better polygon count for our game. And we're going to polyextrude it out just a little bit, just so it has some thickness. And then we're going to go in and put a null node down, which will define our low res out. So we're going to spit that out of here by selecting that, extracting that into a separate object. So now you'll see we have two objects. This is the high res soccer ball, and this is the new extracted low res soccer ball. Now the high res one, display flag is not on the right place, so we got to dive in and put the display flag at the end. That will get it working properly. And now we're going to go into the low-res one and add some new UVs. Now we could use UV flatten again, but for this one we're just going to do a UV project, and we're going to use a polar projection. And we'll just initialize that. And if we look at the view, you'll see. Now it's important if you're going to bake onto something, it has to have UVs. Those UVs don't have to be the same as the source texture that's coming in. Now we go in and we say, go back to this level, and we're going to display both of these objects. So we've got the soccer ball, the low-res soccer ball, and now we want to do the baking. So we go to a shelf tool called the Game Development Tool Shelf. There's a Games Baker node there, which allow us to set up the low-res mesh and the high-res mesh. And then just press render. And it's going to create a base color and a normal map texture. We could also create other maps, but for now we're just going to build those two. Now we're going to test this by bringing a new material over, and we're going to assign the two textures that we just rendered out. So we're going to create the base color, and we're also going to go to the bumps and normals and get the normal map. And we'll just do a flip and Y. We'll make that look better. Okay, good. So now we have our soccer ball. Even though it's a low-res flat soccer ball, it's got a bit of the depth that we had before and some of the shading. And now what we'd like to do is use this in a dynamic simulation that we'll take out to Unreal 4. To do this, we'll be using the Dynamics or DOPS section of Houdini, and let's get started. We'll start by putting a cube into the scene. What we're going to do is we want to create a bunch of soccer balls. So we're going to move this cube, make it a little bit bigger. We're going to dive down to the geometry level, add some more geometry, so we're basically getting 3 by 3 by 3. We're going to transform that up and rotate it around. And by doing this, we create a bunch of points on this cube that we can copy the soccer ball to. So back at the object level, we're going to say instance objects, pick the soccer ball, and now we've got soccer balls on all the corners of there. And if we now press play, we put a ground plane in, press play, there we go. Now we've got the soccer balls animating using the dynamic simulation. We can put the texture map that we just created for the low-res geometry back onto those soccer balls. And we can go down to the DOPS level where we can actually adjust some of the parameters on the soccer balls just to make them a little bit bouncier. Get a slightly different result there. So once we have this animated in Houdini, how do we get this out into Unreal? And again, we're going to go to the Game Development Tool Shelf, and there's a tool called RBD to FBX. And it's going to allow me to go and get that RBD object, the box object that we created, and let me render that out. That's going to render it out using bones, and we can import it back as 3 different parts. So if we're Unreal, we can bring it in as, there's the soccer balls themselves. Then we can use an animation asset to create some motion in there. And we can use the texture maps we created earlier to assign a material in Unreal. And now we have the soccer balls using the same motion we created in Houdini here in Unreal. Okay, well, let's look at another way of getting stuff into the Unreal Engine. So before we baked it out as a geometry sequence, as bones, animated bones, what we'd like to do is bring the procedural nature of Houdini into Unreal as well. What this means is we want the nodes and networks to maintain their flow of data while existing within the Unreal Engine environment. Now, the way we do this is if you go back and look at the way Houdini is set up, we know that everything you do in Houdini creates nodes, and those nodes get connected to build networks. Each network defines a recipe, and the recipe can be used over and over and over again. Now, once you've got that, you can then export as a Houdini digital asset. So that means you take the nodes, collapse them into a single asset with those nodes inside, and then you promote parameters from the nodes inside to create a high-level interface. Now once you have this, You can also add things like animation clips, inputs, outputs, scripts, geometry, textures. A lot of stuff can be stuffed into these assets and be carried forward, and it can be carried forward to be shared with other people. And that's, of course, what Houdini artists generally do, is they build up a digital asset and they share it with another Houdini artist. But what if you want to bring that into something else, something like Unreal Engine 4 or Unity? Well, in order to do that, what Side Effects created was something called the Houdini Engine. And the Houdini Engine is a plugin for these applications. And if you open a digital asset into these applications, Houdini Engine will kick in and cook the nodes. Basically, go through the node, figure out the solution, and deliver the results back to the host application. And then if you manipulate any of the sliders, it will also recook it and bring it back into the host application. You can also do it with other applications like Maya or 3D Studio Max. And there's also a Engine API, which is available on GitHub. If you have a custom application you would like to plug into, you can certainly do that using the Houdini Engine. So let's take a look at how we do this. Let's make a Houdini digital asset and bring it over into Unreal. We're going to start with just a grid. We are going to create a box, and we're going to copy that box to the different points of the grid. We're then going to put a scatter node down. That will allow us to scatter points. Now, if we go back, we want to scatter all the points. Maybe reduce it to 250, relax the iterations. Then we're going to take the box and we're going to make it sit on the ground, and we're going to make it a little higher just so we have these little objects here. Then we're going to go in and add some nodes, some attributes for randomizing. Well, we could randomize color, but we'd prefer to do the normal, and we'll set the that to not rotate around Y. And then we'll take that and we'll copy that and create a second one for scale. And this time we'll use P-scale, and we'll set that from 0.5 to 2. So now we've got randomization in both rotation and in scale. We're going to take all those nodes and we're going to collapse them into a digital asset, and we're going to put those on disk inside our project here and call it populate.hda. Now this populate asset, we'll just take it and let's test it out. Let's import it in. So we're going to import the populate and drag it over, and there we go. The only problem is right now this is a bit of a dumb asset. It doesn't do anything more than I can move it around, but none of the procedural controls in Houdini are available to me. So I'm going to go in and take the nodes below and start dragging parameters up, like the number of instances from the scatter node or the size of the grid. Now once we have that, we can save that. We can then press rebuild here in Unreal. And now we have these sliders, so we can go in and make changes. So in this case here, Houdini is under the surface, making these changes and delivering the results back to Unreal. And you can put more than one of these in a scene or in a level. You can also put these in many, many different levels. And in all cases, they're referencing that file on disk. So we can go back and make more changes. So for instance, we can make them into instancing. So now when we go into here, you'll see there's an instance object there. And that actually, we have built in the ability to replace that instance object, that cube that we put in, with other objects from your Unreal environment. So we put in these bushes. We can also go in and say make a copy, and this time we're going to put in a rock. We'll make that 0.1, 0.1, 0.1. And now we've got the rocks and the bushes set up using this technique. And we can go further. We can add another one if we want. And this time we might go in and say, let's put just a nice simple box there, and we'll make that part of a garden. And there we go, we have a nice little garden that we can walk around and connect to. And this is all positioned, the population of this garden is all done using this tool we created in Houdini and saved out as a digital asset. So in the second chapter of the book, you will use this technique to build up the digital asset for populating the garden. You will also use the same asset to, instead of populating a normal grid, you'll learn how to populate the surface of the staircase and then populate that with something else, like for instance this fire effect. You also build this tower, which will teach you how to do collision geometry groups so that you set that up properly for your game. And you'll also export, much like we did with the soccer ball, export out this dynamic simulation of this wall smashing and get that into the game as well. The final chapter involves volume-based height fields to build terrains. So in this case, you start off with a simple height field. This is defined as a volume. And as you go in and start layering other nodes to it, you can do things like add noise and blur, add a distortion and more detailed noise onto that. You can then remap it. So in this case, a ramp was used to remap it so that not only did we get different positions for the heights, but also we got that little plateau around the sort of the base of the landscape. Then you go in and we can run an erosion node. In this case, you press play. It actually erodes the landscape and starts giving you details like the rivers and valleys and smoothing things out. And then from there we can mask out different features. Find, for instance, the peaks and the valleys and different details like that. We can then visualize the results. And then we can isolate results. For instance, we can use a mask to find specifically that area, that plateau area that we created. And then we can say, you know what, we want to populate that. So now we use a scatter node specifically designed to adhere to a height field. That can then be used copy to points, just like we did before with the populate tool, to copy a bunch of trees to that. And then we get our landscape with the trees and everything working together. And we merge that together. Once you finish that, you can export that out. If you wrap it up as a digital asset and export that out, it will actually come into Unreal Engine as a native Unreal terrain or landscape. And then you can begin to work with it from there. You can also go in and add in some texture, add in details like bushes, and then press play and walk around the landscape. So there we go. We've now gone through the different chapters that are available in this Houdini Foundations book. We have our introduction chapter and the 3 tutorials. So to get access to this, you can go to the SideEffects.com website. SideEffects.com/learn will take you to the Learning Path section, and from there you can go to the Game Tools section where this tutorial is available, along with a whole bunch of other tutorials on making games, working with game development tools, and so on and so forth. There are a whole wealth of tutorials on the SideEffects.com website. A lot of people from the community have contributed their ideas and their tutorials, as well as a bunch of them from SideEffects. There's also great forums and social media, so if you want to learn further and interact with other parts of the community, we have forums on the SideEffects.com website. There's Facebook pages. There's also a Discord channel called Think Procedural. You can go in there and meet with a lot of other game developers and talk to them about your work. Well, thank you very much. I hope you get an opportunity to download the Houdini Foundations book and run through it yourself. And have a great day.